record button now, so we will have a recording of this. Okay, good evening, everyone. Per our custom, I'm going to talk. I have some talking points here that I'll talk to, and I don't know how much these things are changing, but anyway, I will talk to those. I'll give Linda a chance to talk. Your questions are always welcome, but certainly there's a point in this preamble where we'll ask for your questions. So that's what's going to happen. And then the content tonight is, again, I'm going to give you a glimpse of grace notes. We'll talk about what the grace notes look like for confidence intervals and hypothesis testing. And then we will talk and we'll do problems about confidence intervals, proportions, and means, and we'll also talk about using confidence intervals to do hypothesis testing. And I don't know if we'll finish all this stuff tonight, but if we did, we finished the statistics course, and you know, some students will say, oh, that means we take a week off. No, what we will do is we'll just start on the physics whenever we're finished with this. But this is going to be a bright line that will be happening, because when we finish the confidence intervals and the hypothesis testing, that's going to be everything that's going to be on the midterm. And we'll talk about the midterm some tonight, and we'll talk about the midterm some more next week, because we have a whole, let's see, today is the 6th, and so we have 12 days before the midterm happens. Okay, so anyway, here we go. This is the end of week 7. Next week is week 8. And so we're pretty much at the midterm, and we're ready to have the midterm. Although for technical reasons, we're having the midterm in the VCM meeting on 10/18 from 6 to 7:15. And that means that you'll just come to class. Now, actually, you're not going to be coming to class the same way, though, because there will be a Zoom address that you will be going to, so that we can, I guess, watch you a little bit better and maybe have breakout rooms and things like that. And Linda and I are going to be, staffing this, but that's how it go happen. And we will have a dry run next week, because you see, we have to be able to see you. And that means that we need to be able to see your the face, and we need to see your workspace and things like that. So that means there's going to be sort of a cell phone protocol and stuff like that. And so we're going to invest some serious time, as we always have to, in a VCM, talking about how we're going to proctor that exam in a VCM setting. But anyway, that's what's going to happen there. So this is week 7. Just a cockpit commentary. We're on course and we're on schedule. We're just fine, and we're going to have half the term we're going to spend doing physics, and half the term we'll have done statistics, and that should be good. And those of you who have textbooks or are looking at the textbooks, we've done chapters, I'm going to say 1 through 7. And that doesn't mean we've done every topic, but we've done them as much as we're going to, and it's pretty much done. And chapter 9 has been launched, and in fact, chapter 9 deals with the confidence intervals, and then we'll talk a little bit about using confidence intervals for hypothesis testing. So we're pretty much done. I just posted a video, and this was probably sometime after 4 o'clock. I did let you guys know, but it deals with hypothesis testing. I think it's a good video, and I encourage you to watch it. And in there, I shared another LSA with you, but someone already has watched this. Somebody's really on top of this, and they've watched it, and there's been some clarification requested, because they were trying to say, have we had 8 or 9 LSAs? So someone has requested clarification, and I'll look into that and figure that out and let you know. I'm not giving you penalties for submitting LSAs late and things like that, but I encourage you to do it for 2 reasons. Number one, it helps you to prepare for the high stakes assessment, and also it will be a cushion for your grade, because these things will be graded gently. Okay, and I will be, and I'm working on this, although sometimes other things get in the way. But I am working on a solution commentary and sharing year-to-date grades. But I think you'll be happy with that, because this will be a cushion, really, for everybody. You know, they kind of say, "Oh, gee, I'm in pretty good shape right now." So that will be happening. Let's see what else is here, Linda. The study guide is in preparation. Now, my study guide is not like some students are used to study guides. I'm going to tell you topics, and Linda has seen the draft exam and she made some comments, and I'm changing it because I value her comments. So I'm changing it, and I'll share with her, the final thing. And so certainly interacting with Linda for that will be good. And I will give you my own version of a study guide. Now, this is not like many students, they'll come from high school, and on the day before the test in high school, the students say that's the only day they have to come to class, because the teacher hands out exactly the test, except for maybe one or two numbers changed. Sometimes they don't even change the numbers, and so the students can Google it, or go with Chegg or something like that to try and find out what the answers are, and then they say then they're prepared for the test. It won't be like that. What I am going to do is I'm going to tell you, what kind of problems. I'll say, oh yes, there's a regression problem, and you need to know what a regression problem is. That's the linear regression stuff, which deals with the chapter 4 that we did and things like that. So anyway, that's what's going on. I'm getting a phone call. I just need to check and make sure it's not my daughter. I'm pulling it out of my pocket. Oh, it is. Hey, Beth, I'm teaching right now. Bye. Okay, I will call her back in a bit. She'll probably text me with something, what she wanted to say. Except she usually texts me to start with. Linda, can you still hear me?
Yes, I can.
All right, it's your turn then.
Okay. Nobody did show up to the guided study group today, so that was just a little bit concerning with us getting so close to the midterm, but hopefully that just means that you guys are all doing great. I have seen the midterm, at least as a work in progress, so I can help you guys start getting ready for that even if we don't have the study guide yet, so maybe time to make GSG a priority if you haven't already.
Okay, and Linda, let's just do a little bit of the let's do a little bit of a poll, and you might have already thought about that, and how you do the poll, but we'll find out how the students think they're doing. And again, and it's not only the GSGs. I know I actually caught an 1120 student working with Cheryl Martin the other day, and they were smiling because Cheryl's a wonderful person to work with. So anyway, Linda's got a poll here, and again, this is an anonymous poll. We don't know who's saying what. And so, you can be honest and things. We're just trying to get about how are people doing, things like that. And a bunch of people aren't coming to class. I don't know if that means the videos are good, or I don't know what that means. But anyway, so you do respond here. Well, it would have been great to see some pretty good actuallys, but it looks like we're not going to get any of those. And it's almost an even split. So I think there probably should be people, wanting to attend the Monica. I'll call on you in just a minute, if and I wasn't sure if that was a raising your hand or something. We're almost to the student Q&A. I guess we can be there. Monica, did you have something you wanted to say?
Sorry, that was an accident.
Okay, and I mean, don't worry. I just didn't want to miss a comment or something that you had. Okay, I'm going to count to 10, Mississippi, for student Q&As and things like that. Oh, and now, and either Monica made another mistake or she does have something. Monica, what's up?
No, actually, I just thought of a question. So for the exam, 'cause I know it's proctored, like, do you know how that's gonna be set up, like, as far as, like, getting a
Yes,
grace
yeah,
note and...
yes, I do. But the rollout of that, and by the way, we might fine tune that a bit, Linda and I. But you see this this bullet point here that says dry run next week.
Okay.
And so the dry run next week, and it'll happen during the VCM time, but we'll say, okay, everybody take out your phone um, and I want you to set up. My screen just went blank, but then it came back. I don't know what that means. Linda, you can still hear me?
Yeah, I can still hear and
Okay.
see.
Okay, so I don't know what that was, and it probably doesn't matter. So Monica, anyway, that will be happening. Yes, we know we're fine tuning it, but the dry run next week will be useful for you doing that because then you'll be able to say. I mean, in fact, I'm just going to. In fact, Linda, and I didn't rehearse this, and I didn't ask Linda to be prepared to make remarks. But Linda, do you want to tell them just in general how it works with, you know, duct taping their cell phone to the wall, and it's not really, you don't have to duct tape it, but you want to tell them sort of generally what we've done in the past with this zooming stuff?
Yeah, so you're going to be using your cell phone as the main camera that's going to be, I guess, proctoring you. So we'll see basically you, your work area, and your laptop screen. So you'll need to angle your phone and put it in such a place where it's charging, because you don't want it to die in the middle of the exam. And you can also get all three of those things in one shot. Then from there, then you'll be using your laptop to be actually taking the exam.
And that means there's going to be an answer sheet in Blackboard, and the answer sheet's going to be the primary grading instrument. So if you don't put an answer in the answer sheet, that's not good. And so, you know, and so that's what we're going to be doing. And that's some headline stuff. And Monica, I'm not blowing you off, but I'm just saying, you know, maybe some more details during the dry run next week.
Okay, thank you.
That's probably the best you're going to get today. And we're not being, you know, I mean, I completely turned Linda loose, and that's what she was able to tell you. So I think that's good. Okay, any other thing? I'm starting my count again. Okay, your questions are always welcome, but now we're going to leap into content. And Linda, how are you feeling today? Are you recovering from this flu shot?
Yeah, for the most part, I'm feeling a little bit better.
Okay, great. I advanced the slide, okay, and these are going to be grace notes. And I will tell you that the proctoring in this class is a little bit um, different than proctoring in some classes, because I give you grace notes, and so you have all of these grace notes, which from my, you know, thought is everything you need to know. There's a lot of classes that I teach where students have to memorize things, and then the element that we have to be concerned about as proctoring is, oh gee, did they write on their wrist a formula or something? And you know, we don't have to think about that at all, because I'm basically giving you all the formulas there. You just have to know how to use them. And there's not going to be a lot of and I don't know, Linda may feel differently about this, and we might discuss it, but I think you're going to be pretty busy during the time that you have to take the test just doing the test. And so there's not a lot of time to be, you know, Googling, you know, what is the standard deviation on Google or something like that, you know, to help you answer a question. It's going to be really pretty much, you know, focused on completing the problems. So anyway, this is the grace notes that are going to be there for the um, hypothesis testing and also for the confidence interval. So, and these are formulas that we're going to be using tonight. And so, and again, I don't know, we'll see how this plays out, but Linda might be reaching back and grabbing some of these formulas or reminding you of some of these formulas as we're doing. Now, there are two confidence intervals that we can have, and it's important that you read the problem to determine which one. The first one that has the confidence interval for P, that's for the proportion. And a proportion is a ratio, and it's like 2/3 or something like that. It would be a proportion. Sometimes it's a percentage, and let's say 37% of the people feel this way. But that is a confidence interval for a proportion. And you see what you have is you have a left endpoint for the confidence interval that is p hat minus z alpha over 2 times that square root p hat times 1 minus p hat all by n. And that's something you want to plug into Excel probably. But then I also might ask you to demonstrate that the requirements are satisfied, and it says provided these are the requirements, n times p hat times 1 minus p hat has to be bigger than or equal to 10. You'll just say, well, Jim wouldn't ask us the question unless it was, but I'll say, what is n times p hat times 1 minus p hat? And so you have to say, oh, it's 53, or whatever the number is. And you also are supposed to say that the sample is not more than 1 over 20 of the total population if it is a finite population. And actually, populations usually are finite at any point in time. Okay, so that's dealing with a proportion. We've got videos on that and everything else that I've made and published. But then the second bullet point is a different confidence interval. And this confidence interval is a confidence interval for mu, that is the population mean. And this is going to be x bar, and that's going to be plus or minus t alpha over 2. And you might say, wow, what happened to the z? Well, this is a t distribution, and that's s over the square root of n. And t alpha over 2 has something like n minus 1 degrees of freedom. Now, again, I have shown you videos on this, and when I say shown, I mean I've published them, asked you to watch them, and things like that. And maybe you have, maybe you haven't, I don't know. Maybe that's why some of you said, well, I'm not really there yet. Well, you want to be watching these, but we're going to work some problems with this too. But you have to know which formula do you use by reading the problem. Okay, and then there are some requirements there too. It says that either the sample is bigger than or equal to 30, or the underlying population was normal, or and n is less than or equal to 1 over 20 times the whole size of the population. And then I just published when I say published, I mean I posted on YouTube and let you know, and I realize some of you haven't seen that yet, but some hypothesis testing. But actually the hypothesis testing is going to be reasonably easy because we're going to be doing this not some of the fancy ways that Linda would know how to do this, but we're going to be doing this with confidence intervals. And Linda, just to speak in a little bit of code for you, when we're doing that, we're not so much worrying about left and right. We're really just doing two-sided kind of things, except well, I don't know. I guess I'm doing a little bit of each. But if we're using confidence intervals, a confidence interval is the middle 95%. So you know what I'm saying with all that. So anyway, so I'm kind of treating that in an accelerated fashion, and I found that I think it's possible for us to add another useful component to the course. But this will be the end of what we do. Okay, so let's go into the thing then, and let's jump right into I think we're not going to do that. We could, but here's the normal table, Linda, if you need it. And here's the other normal table if you need it. But Linda, would you like to talk to the students? And maybe you will, maybe not, but why is that bottom part of the graph that I have especially useful for the students? And this will be in their grace notes as well.
So if they look at the bottom left-hand corner, then they actually give you the critical values for Z sub alpha over 2 already. So you don't even need to look them up in the table. They're already given to you in that smaller table on the bottom left-hand corner.
So that means they can work ever more swiftly, you know, on the exam because they know that information is there. And so those are the coefficients. And Linda, as you know, and I guess I didn't even need to say that. I guess I'm talking to the students, but those are Z alpha over 2. Those aren't T alpha over 2. And here is, well, that's for the, let me, wait, I thought I had T alpha over 2 there too. I don't have that? I don't have that table. There it is, I found it. This table really should be somewhere else. But Linda, here's T alpha over 2, and we're going to talk about that tonight a little bit. And Linda will help explain that to you, at least if she's still here, and I suspect she probably will be. Okay, so let's dive in now and do some problems. Now here again is just the population proportion equations, and you got a left bound and a right bound. And so a note, it must be the case that n p hat times 1 minus p hat must be bigger than or equal to 10, and so on. And so we'll talk about that, but now we're going to do a problem. And Linda, I didn't actually, Linda, we might have done this after you left, but I think I did this last time, didn't I? I think I did this problem last time, but we're going to do another one. And this is the one we're going to use, and this is phone in the John, okay? And Linda, I'm going to give you an opportunity, to do this, and you could either do it or refuse to do it, you know, depending on, you know, what you think at the time. But I'm going to read this, and Linda might be copying it and kind of getting ready. Okay, so I'm reading the problem, though. All right. And this could be a problem on the exam now. It probably isn't because I'm doing it right now, but anyway. In a survey conducted by the marketing agency 11 Mark, 241 of 1,000 adults 19 years of age or older confessed to bringing and using their cell phone every trip to the bathroom. Confessions included texting and answering phone calls. Now, by the way, on occasion, I do go into the restroom at the College DuPage, and I have found people doing this. And again, I'm not spying. I'm not conducting this survey. I'm not really interested, but there are some people that do this. So anyway, this ad agency, this market agency, and I have no idea why they wanted to do this. Maybe someone was paying them to do it, but they reached, maybe it has to do with the waterproofing of the phones. I don't know. But anyway, they called people or interviewed 1,000 randomly selected adults, and 241 of them, you know, confessed to doing this. Okay, now you have to think about what kind of a thing this is, and there's not a key word, I guess here, except what really is going on is, and I guess there's a key later, but the way somebody answers that is they would say, hey, every time you go to the bathroom, do you bring and use your cell phone? And the answer to that is either yes or no. That makes this into a proportion. Okay, and there's some talking about, is this qualitative or quantitative and stuff like that. What I really want to focus on is, based on the results of this study, what is the point estimate for the proportion? And by the way, if you read that far, you'd see the word proportion and you say, oh, it is a proportion problem, but I figured that out already. So the proportion of adults 19 years of age or older who bring their cell phone every trip to the bathroom. But you see, you've got a point. This question's asking you, what is the point estimate? Okay. But then, so we're really just saying C, E, and F, I think is what we're doing. So C is what's the point estimate? So that's what did you learn from that. But then there is a part E that says construct and interpret a 95% confidence interval for the population proportion, not your sample, but what do you really think happened with the population of adults 19 years of age or older who bring their cell phones every trip to the bathroom? And then F, it says, what ensures that the results of the study are representative of all adults 19 years or older? And that's the fact that you had to do a random study. You had to randomly get a random sample to do that. So I guess only, Linda, it's going to be C and C and E, yeah. Okay, so you feel like running with this, or
Yeah, I can do that.
all right, great. Now you want to listen to Linda's treatment of this, though, because and she's really just doing, I guess it's C and E. I'll go ahead and Linda, you have the ball.
Okay. So to get your point estimate, then all we're doing here is just using the sample that we already have. So in this case, that would be the 241 out of the 1,000 adults. So to get p hat, then all I'm doing is equals 241 divided by that 1,000. And I'm going to make a note that n equals 1,000 in this case. But really, that would be it for problem C. Any questions on that? Okay, I'll take that as a good sign. So for E, then first thing I'm going to do is figure out what all my missing pieces are, and then I'll take it from there. So I have p hat. I'm going to find out what 1 minus p hat is. So I'm literally just doing 1 minus and then taking that p hat value that I just got. So now what I need is that z sub alpha over 2. Now they're doing a 95% confidence interval. So I'm going to go back to that PowerPoint, and we can actually steal that from the table. So let's see. For a 95% confidence interval, that would be the second line right here. So my z sub alpha over 2 is going to be 1.96. Can everyone see that?
Yes.
Okay. So then I'll go back to Excel. And I'm just labeling this so we don't lose track of what's what. And this is 1.96. Now what I like to do is actually compute what's on the right-hand side of the minus and plus. That way I can just add and subtract separately. And often this is called the margin of error. So I'm going to say E equals, and then over here I'm going to do my z sub alpha over 2 times, and then I'm going to open a parenthesis. I'll be raising all of this to the 1/2 power once I'm done. But this is p hat times 1 minus p hat divided by n. And then I'm raising those parentheses to the 0.5 power. That's going to be my square root. So that's my margin of error. Then to get my lower bound, then I'm going to do p hat minus the margin of error. To get my upper bound, I'm going to do p hat plus the margin of error. So then my 95% confidence interval would start at 0.21 and go until 0.267. Any questions on this?
Amber has her hand up.
For the lower bound, what did you say you did?
So the lower bound is just the p hat minus the margin of error.
Okay.
So once I computed all that, then I just did the p hat minus that number to get the 0.21.
Okay, I see it now. Thank you.
Yep. Any other questions?
I have two, Linda.
Okay.
And I realize I'm coming out of left field with this, but just looking ahead to hypothesis testing, suppose someone said, I don't think, I think it is less than 25% or less than 1 out of 4 people take their cell phone to the bathroom, okay, every time. So if someone did that, made that hypothesis, and they said, yeah, no, it's less than, or let's see, what did I want to say? It's less than 25%. You know, that of the people take their cell phone to the bathroom, and then you did the study. I think that might be me. I was going to blame it on 7, but then I realized where my microphone was. How would these results? How would you react, Linda, to that if someone was saying, "Well, I don't think P is not 0.25." What would you tell them based on this confidence interval result?
So based on our confidence interval, since 0.25 does fall within the bounds, then we can't rule that out as being the actual population proportion of adults that bring their cell phone to the bathroom.
Okay, that's great. And Linda, I know this also wasn't a question that was explicitly there, but suppose I asked the question, and I could, if I were writing a question instead of ripping one out of the book, I could say, hey, show me, or what do you get if, I could say something like, oh, n times p hat times 1 minus p hat must be bigger than or equal to 10. What is n times p hat times 1 minus p hat for this problem?
Well, I'll throw that into Excel real quick. So we're doing n times p hat times 1 minus p hat, and that is definitely bigger than 10.
Yeah, that's a big old number. Yeah. Okay. All right. And again, we're about ready to move on to this, unless you guys have questions you want to ask of Linda about how she did something or how to do it. But I think this is a great example of just doing a proportion. And by the way, that was a 95% confidence interval. That means that Linda is not 100% sure of her answer, but she has a great deal of confidence. She knows if she did this with different samples, what would I will answer that question that was popped in the comments there. I'm trying to think of what I was going to say. Oh, if Linda did this same experiment and she went out and she got another 1,000 people and so on and so forth, 95 times out of 100, the population proportion would be in that interval. Okay, someone asked how I would answer F, and I'm going to give my answer again, and Linda, I'll see if there's anything else you might want to say about that. What ensures that the results of this study are representative of all adults 19 years of age or older? Well, I would say that I got a good sample. I got a random sample, and either I got that from, doing random sampling from a phone book or something like that, but that ensures that I've got a chance to be here. Now, I still could be wrong about that, but I say, oh, 95 times out of 100 doing this process with random sampling is going to be give me right. That's the answer I would give. Linda, you might want to improve on that answer. I don't know.
No, I think that's pretty much good.
Okay, thank you. All right, so there we go. That's good. And Linda, since you went to Excel, I'm going to let you go back to the PowerPoint slides, but that's where we're going. And I am, Linda, paying attention, and I remembered that this was Wednesday and stuff like that. So, all right, so what we did was we did the problem called Phone in the John. Now I'm going to advance the slide and we're going to look for something else. Now this is a little bit, and Linda, what you might want to do is pick one of these, either one or two, and you know, we'll talk about this, but we're going to teach you how to use the table. Okay. Now in the table, and Linda, this is I thought about this, and in fact, we're going to ignore if it is right tail, left tail. We're always going to be talking about two tails, and we're always going to be talking about T alpha over 2. Okay, so Linda, I don't know, you can pick problem 1 or 2. And again, you always can say, no, I don't want to do that. Why don't you do that? But pick problem number 1 or 2, and we're going to go to the T table, and we're going to practice looking up values of T alpha over 2. And everybody should realize that the formula is going to have T alpha over 2, not T alpha. So you have to think about that, and don't pay any attention to this right-handed and left-handed stuff. The thing that Linda is focusing on is degrees of freedom, or sometimes it says what N is, and things like that. So Linda, are you, and first of all, are you up for doing this?
Yeah, that's fine.
Okay, so rip out either 1 or 2 and go there, and I'll just let you talk a little bit. See, Linda's reminding you of how to use the table. Now, I actually explained that in the video I posted on YouTube, but some of you might say, boy, Jim, I've been busy, and I can believe that. I think we're all busy. But along the way, you want to watch that video, but now you're having Linda explain it kind of in real time, and you have an opportunity to ask Linda or me questions. So Linda, please, if you will, go ahead, and you're talking about that T table, and there is a T table in there somewhere. I think I put it in the wrong place, but
yeah, it's on the next slide.
Okay, good.
So if we're doing number 1, then we have alpha as 0.01 with 15 degrees of freedom. And that is a little bit small, but you can zoom in. Now, when they say area in the right tail, that is half of your alpha value. So if alpha was 0.01, then our area in the right tail is going to be 0.005. So I'm looking in that 4th to the right column, and I'm seeing if there's like a pointer tool I could use, but I'm not seeing one.
You could probably grab, is that crayon up there? Can you do that?
There we go.
Oh, okay.
So that is the column that I'm looking in. And then we said there were 15 degrees of freedom. So I'm looking at this row right there. And then if I look across and I see where they intersect, then I'm getting 2.947. Does everyone see how I got that? Okay.
All right.
So then
Okay.
going back, then for part B, we have a 0.05 level of significance with a sample size of n equaling 20. So your degrees of freedom is going to be the sample size minus 1. So in this case, we have 19 degrees of freedom. And alpha divided by 2, well, 0.05 divided by 2 would give us 0.025. So I can go back to my table, zoom in a bit, and then I'm looking in the column that has that 0.025. And let's see if I can change the color. Okay. I can, I just can't move it. Okay, so my 0.025 is right there. And then we said there were 19 degrees of freedom, so I'm looking in that 19 row. And if I find where these intersect, then that is going to get me that 2.093.
Now, Linda is extremely knowledgeable about this, and the problem didn't say there were 19 degrees of freedom directly, but Linda inferred that there were 19 degrees of freedom from things that she knew, because she knows for this statistical operation that the degrees of freedom is n minus 1, where n is the number that is in the sample. So the problem itself, I think, said n was 20, but Linda knows that the degrees of freedom for this statistical thing is going to be n minus 1. So that's how she knew 19.
Okay. So then going to part C,
Monica,
then I have,
did you see Monica's question? She said, why 0.25, Linda, on B?
because we did 0.05 divided by 2.
It's called T alpha over 2.
Okay. So for part C, then my alpha value is the same. So I'm going to be looking in the same column, but it's going to be a different row since n is now 13, which means I have 12 degrees of freedom, since 13 minus 1 gets me to 12. So I'm going to look in the row that has a 12. And let's see, that would be right there. So if I go over to the 0.025, then that would give me 2.179. Did I lose anybody with this? Or is it kind of making sense? Okay, that's what I like to hear. Professor Bradley,
Okay.
anything else you want to add?
I don't think so. I think that was a good job, Linda, as always. Can we go back then to the slideshow then and see where we
We're
are?
already on it.
Okay, now this, I'm going to advance the slide. Now that was just a little exercise in using the table, and there's the table. But now we have a different formula, you see, because this time you have to understand that the question is not about the proportion of people that feel one way or the other. It is about the average or the mean that we know about. Okay, so we have all of this stuff going on here, and there are some things that also are required. For example, the data comes from a population that is normally distributed, or the sample size is bigger than or equal to 30, or and you have that in less than or equal to 1 over 20 of the sample size. But anyway, this is and it is a different distribution. Okay, but you have the lower bound, but this time there's no p hat. From your sample you're getting x bar, so you have to have the the average, so that is x bar, and the left endpoint is x bar minus T alpha over 2 times S, and S is the standard deviation of the sample divided by the square root of n, where that is the sample size. And the upper bound is x bar plus T alpha over 2 times S over square root of n. And T alpha over 2 is the critical value with n minus 1. There's where the n minus 1 degrees of freedom come from. Now this is in the grace notes, all this stuff, so you don't have to memorize this or anything else, but I'm going to ask Linda to give one of these problems actually a go. And I need to think if I like this problem, and that's about Tootsie Pops. I don't like that problem so much. I don't like this problem as much. I mean, I like the problems, they're fine, and who knows, I might even ask you these things on the test, but I'm trying to make the best value of Linda that we have, and we're here. Now, Linda, I'm picking this problem for you to do, and you'll probably figure out why I'm having you do this one, okay? So I'm going to read this, and I'm going to say some things, and then I'm going to turn Linda loose on it, and she's going to do the problem, okay? And Linda, some of this we're not going to do, but we'll do some of these. Okay, so this is about the pH of rain. And pH is kind of a chemistry thing, I guess it's chemistry. And it has to do with whether something is an acid or a base, okay? And you have probably heard in the news and stuff about acid rain, and acid rain is not a good thing. So anyway, people are concerned about this. So anyway, the following data represent the pH of rain for a random sample of 12 rain dates in this West Virginia place. Now, they tell you that a normal probability distribution suggests the data could come from a normal population. That means it is okay, and a box plot indicates there are no outliers. All that business means that it's okay to use the t distribution. But you have raw data here, and it looks like you have 12 data points, okay? So these are 12 days it rained, and they said, what was the pH level of the rain that they got? Okay, now they say determine a point estimate of the population mean. So you have to come up with this time it is X bar. And then they want you, and Linda, I'm going to do something different. Let's skip down, and we're going to do C, construct and interpret a 99% confidence interval for the mean. And we're just going to do A and C, okay?
Sounds good.
But this thing is different for a number of reasons. And the big reason is, and Linda will, refine this, but the big reason is I gave you a pile of data. I did not give you summary statistics on the sample. Okay, so Linda, go ahead if you will, please.
Okay, let me share my screen. Can everyone see this okay?
Yes.
All right, so I've already taken the liberty of typing out all the data for us, but the reason why this problem is different is we don't have the mean and standard deviation given. So we actually need to use those Excel formulas that we learned about way back when. So I'm going to call this X bar.
And that's good review, I think, yeah.
It very much is. So for the mean, we use the equals average formula. And I can highlight my data, close the parenthesis, and hit enter. And then I also need my standard deviation, but since we're using S, and since this is a sample, then I need to be careful and make sure that I'm using the correct formula. So that's going to be stdev.s for a sample instead of .p for a population. So I open my parenthesis, highlight my data, close the parenthesis, and hit enter. And now it's just like those numbers were given to us in the problem. Any questions on those? Okay. Then next, looking at these equations that we have, then I'm still missing the T sub alpha over 2, and I'm still missing the N. But Professor Bradley did say earlier that we had 12 data points, so I'm good with that. And then just so we have it, then N minus 1 would be my degrees of freedom. So that would be 11 in this case, since 12 minus 1 would be 11. Okay? So if we're finding a 99% confidence interval, then that means alpha is that 1%. So that is 0.01. Now I'm going to go back to the PowerPoint, and then we can look at that t-table. So if alpha is 0.01, then alpha over 2 is going to be 0.005. So I'm looking in this column again. Then if I have 11 degrees of freedom, then I'm looking in this row on top, and that's going to give me 3.106. So that is going to be my critical value here. So then T will be 3.106. Any questions so far? I'll take that as a no. So first thing I'm going to do is compute my margin of error again. That's just the thing that's being plus and minus. So in this case, that is my T sub alpha over 2 times, and then I'm going to take my standard deviation and divide that by the square root of n. So I'm putting n in parentheses, and I'm raising that to the 0.5 power. So I can hit enter, and that is my margin of error. So then to get my confidence interval, then I'm going to do x bar plus my margin of error and x bar minus my margin of error. So I'll start with the minus to get my lower bound, and then I can get my upper bound by doing the plus. So this would be my 99% confidence interval.
So Linda, I have a question or a comment, and I know I'm coming from left field on this, but suppose somebody said, well, I think that the pH of the rain is more than 6. What would you tell them based on this statistical analysis?
I would tell them that that is extremely unlikely, since the confidence interval that we constructed with 99% confidence only goes from 4.6 to like 5.2. So for it to actually be greater than 6 is extremely unusual.
And that's really what we're doing with the hypothesis testing the way I'm doing it. We are going to be setting up the hypotheses and things like that, but we're going to be testing it with confidence intervals. And in fact, I haven't written this part of the test, and I'm not even 100% sure I'm going to have this on the test, but if I did, I could actually give you results that are that have the have a confidence interval in there. I could ask you the same kind of Linda question, because hey, the confidence interval's 4.6 and change and 5.17 and change, and somebody's going around saying their hypothesis is that it's 6. What do you think of that? And that would be an essay question that you would answer in much the same way that Linda did. And Linda, of course, would get full credit for her answer. Now, any other questions of Linda on this one? Okay, I counted to several Mississippis there, Linda. So again, well done. Let's go back to the PowerPoint show.
Okay.
And Linda, I am watching the clock for you, and I know we don't have you much longer today, but that was a blessing having you while we did. And we'll go back. And if you wanted to practice something, you could go back and do the Tootsie Pop. Whoops. The Tootsie Pop thing. I actually remember this commercial. I don't think they probably call that a sucker anymore. They probably call it a lollipop or something. But anyway, I don't know. Maybe they do call it suckers. I don't know. All right. So, and back in the day when my teeth were not as precious as they are now, I would bite into the Tootsie Pop really quickly just to get at the center of the Tootsie Pop. Anyway, you don't care about that. Let's see. Let's look at this one. Okay, I'm just going to read this. The website keeps track of predictions made by individuals in finance and other places. Jim Cramer, he's a wild and crazy guy that has a television program, and he's a famous TV personality. And anyway, They monitored 678 of his stock predictions about whether to buy the stock or not, and 320 were correct things. What kind of a problem is this? A mean or a proportion? And if you read ahead, you see this is a proportion problem. So you could, yeah, proportion, that's good. That's exactly right. The words are there. Here's another thing about filling bottles, and this is juice bottles. And what happens is people are filling juice bottles, and they're supposed to have 64 ounces of juice in there. But because the penalty for underfilling bottles is severe, that means customers get pissed off. That's the severe penalty there. The target mean amount of juice is a little bit over the 64 that's supposed to be in there. But the filling machines, they vary, and so it varies from bottle to bottle. So a quality control manager wishes to verify that the mean amount of juice in each bottle is 64.05 ounces. Now, I carefully planned this period, and the reason I wasn't asking Linda to do this in fact, Linda, why did I not ask you to do this problem instead of the other one?
Probably because this one would have taken longer.
Yeah, there's a whole bag of data points here, yes. But the point of this is that this is a mean problem, and you should have, you read that and you figure out, is there a problem with this thing? Are you filling, too much in there, or is the mean? And you're going, and this actually is a hypothesis test that you could do. Okay, I'm advancing the slide one more time, and wow, I guess I'm about ready to do the hypothesis test. So Linda, I think I kept you late last time, and I'm going to let you leave maybe just a little bit early. I am going to ask you though, how's 7 doing? Okay.
She's doing all right. She's currently taking a nap.
Oh, wow. Well, that sounds like a great activity too. Okay, so Linda, thank you for your contribution today, and enjoy your class. And let's see, and we're going to continue talking for a little bit. The students and I, we're going to talk a little bit about hypothesis testing. Okay. And so here we go, students. I'm taking control of this, and we've got, oh, I don't know, 15 minutes or so to still work. Now, this is the way hypothesis testing works. And that means that, and questions I could ask you is to come up with a null hypothesis or the research hypothesis based on a problem. And I could ask you to actually construct the confidence interval to test it, and so on and so forth. Now, I actually did some pretty nice examples in the in the video where I actually did construct the confidence intervals and things like that. And so, but here's how you start. Okay, so the way this process start is you start with a claim and a value of alpha. Now, alpha is how often you're willing to be wrong. And you see, if I was doing, let's suppose that someone approached me from the local PTA, and they said, "Oh, Jim, we think you know things about statistics. Would you please volunteer your time?" And volunteer means I'm not getting paid anything for doing it, to do a statistical study for me. And it involved doing a survey to come up with a confidence interval for how many people liked the Christmas party last year. Okay, well, first of all, that would be some work because you'd have to go out and get a sample and things like that. And to be truthful about this, I'm not going to care a whole lot because I'm not getting paid to do this, and I'm not really interested in the outcome. I don't have any children in the school, so I'm not active in the parent-teacher association and things like that. So I'm not too interested in this. And what they're really trying to say is, oh, we think 80% of the people liked the Christmas party. Well, the claim is that the proportion who liked the Christmas party was bigger than or equal to, was bigger than 80%. That could be someone says, yeah, I think that's what it is. And that's what they would like for me to show. Okay, so anyway, so I got a claim, and that's going to be that P, the population proportion, is bigger than 80%. But I don't really care about this, so I am not going to pick an alpha that is, I'm just not going to invest a lot of time on this. So I might take alpha to be also, I don't want them to walk away thinking I'm a schmuck either. And so at the time, what I think that's a Yiddish word, and we won't go into what that means. But anyway, what I'm going to do is I probably would say, yeah, I only care about being 90% confident for this result because I'm not really interested in it. Nobody dies or anything like that. It's just somebody who, wants to get patted on the back because of the good Christmas party or something. So anyway, if I don't care too much about it, I'm willing to make that confidence level lower than if I really care about it. Now, I will tell you something that I do care about. I care about educational research that I do. And if I'm doing some research that I'm planning on publishing in an educational journal, the standard is you want to be 95% confident in your results. So you see, I care more about my research that I'm doing about education than I do about the local PTA where I did 90%. Now, sometimes when I am fantasizing about what I really maybe should have done with my life, I think about, maybe I should have done more medical research. But by the way, if you're doing medical research, people can get sick, and worse, people can even die. So there, I want to be 99% confident in my conclusions. In fact, I'd even like to be 100%, but I can't get to 100%, but 99 is pretty good, okay? So you see, you start with a claim, what's this study all about? And you start with an alpha value. And usually this is a word problem. Okay, now, there are two states of nature, and I think I'm repeating my lecture a little bit, but I don't know, maybe it's useful. Okay, so then what happens is my claim becomes either a null hypothesis or an alternative hypothesis. Now, these are going to be states of nature. And I think it was actually 2 periods ago I asked you to watch one lecture on this thing, and that was the lecture from the, what do we call it? Decisions Through Data series. But I made another lecture that I did just on my own about this that helped refine it a little bit. And in fact, this is a chart I took from that presentation. But here's what happened then. You start with a claim, but then your claim will either become the alternative hypothesis or it will become the null hypothesis. But the null hypothesis and the alternative hypothesis are different states of nature. And the null hypothesis always has equal in it. And that means the alternative hypothesis does not have equal in it. And either the null hypothesis is true, the way I'm teaching this to you, or the alternative hypothesis is true. So you start with a claim and a value of alpha. And then you say, well, what is my claim? And your claim is either the null hypothesis or it is the alternative hypothesis. And it depends a little bit on what you're trying to prove, and there's problems that I did in that example. And today, I think in this lecture, I'm talking about different problems, I think. In fact, that's my plan, to talk about different problems. Okay, then what do you do? Well, then you have to go off and get a sample, and you construct an appropriate confidence interval. Now, this is much like what I was asking, the question I was asking Linda. Like, you remember that the confidence interval on the acid rain went from 4.7 to 5.1. And then I said, well, there's this turkey out here who's saying it's 6. Linda, do you think that's very possible? She said, well, no, Jim, because I have a 99% confidence interval that says this is between 4.7 and 5.1. So you see, if that guy says, I think it's equal to 6, you could reject that. Now, here's what your statistical decision is. You either reject or fail to reject H0. And I spent a lot of time in the video talking about, you don't find someone innocent, you find them not guilty. This is the same kind of thing. So either you reject or fail to reject the null hypothesis. But that's a very technical, statistical decision. And what I do expect students to do is to state the conclusion in words. And that's what Linda did when I asked her that. I said, well, there's this guy who thinks the acid rain has a pH of 6. And she said, well, I just did this 99% study and 99% confidence interval, and 6 isn't in there. So I reject the null hypothesis, but that means that guy is wrong, I think. And again, if I probed Linda, I said, Linda, are you 100% sure? She said, well, no, I could be wrong, but I'm pretty sure because of the way I did this. I did it properly with the 99%. So that's what's going on. And I realize I made you live through that lecture probably for the third time, but maybe it took third time because this is actually a little bit subtle. Okay, so let's look at a problem then. Okay. I'm going to read the talk to the animals problem. Okay. So in an American Animal Hospital Association survey, and so they're paying somebody to do this survey for them. People who do surveys, it's actually, I think there's good money in it. There's a lot of political surveys. Anyway, they randomly sampled. They found people, and 37% of the people responded that they talked to their pets on the telephone. Now you might say, boy, that's a stupid question to ask, but actually, sometimes people are interested in stupid questions, and I really don't want to get into that, but we're talking about the statistics. So 37% of the respondents claimed that they talked to the pets on the telephone. Now, a veterinarian found this result hard to believe. Now, the veterinarian either thought that 37 was too high or too low. And it doesn't say what he did. So what we're really going to do here is we test, well, is it really 37%? So the way you would test this is you would go out and grab a sample of a randomly selected 150 pet owners. You see, I'm going out and getting the sample, and I'm going to discover that 54% of them spoke to their pets on the phone. Okay, now I have a question for you all, and I want you to think about this, and I'm going to count to 10 Mississippi to give you time to think about it. Then I'm going to tell you the answer. Is this a proportion problem, or is this a mean problem? And so, I'm going to ask you to, at least put it in your mind, and I'm not doing a poll. If Linda was here, we might do a poll. Linda's not here right now, so we're not going to do that anyway. But is this a proportion problem, or is this going to be a a different kind of problem, a proportion problem? It is a proportion problem. I guess I'm going to say that. It is a proportion, yes. And somebody said that with a question mark. They didn't have to put the question mark there. Or maybe they were saying, is this right? But it is right. This is a proportion problem, and it's all about reading it and thinking about it. So that's a proportion problem, and that's good. Okay, and let's talk about what this might be. Okay, as a proportion problem. So what I'm going to do, and remember that it was 37%. So what I'm going to do is I am going to, well, what do I need to do here? I'm going to share a whiteboard with you, which means that I'm stopping sharing. I'm going to ask Amber because she was here, or no, I can see Monica's still here. Monica, can you see a whiteboard?
Yes.
Okay, good, thank you. Okay, so here what I'm going to do is I'm going to say what is H0 and what is H1. Okay, so if I were doing this hypothesis test, I would say H0, and that's called H naught. And if you haven't watched those videos, you should watch them because they're not bad. But H0, and this is the null hypothesis, and I told you that this has the condition of equality in it. And since this was a proportion, I'm going to say the proportion is equal to, and that's supposed to be an equal sign, and it's not showing up very well, 0.37. And I think Monica did that thing with the other one, and she found p hat for us, which, thank you. I need to find my eraser here to erase this thing. Okay. All right, so now I'm going to go back and try to draw it again. And so this is going to be equal. And this is, the proportion is 0.37, because that's what that guy thinks it is. Okay. All right, and then H1, and by the way, she said it was 0.39, and thank you, Monica, for that. But that means that p hat is 0.39. So to tell you the truth, the thing you really want to test is, you're going to say, well, is it greater than 0.37? This is going to be H1. But this means this is, since these are competing states of nature, either I am less than or equal to 0.37 or I am greater than 0.37. Now, if we had a whole bunch of time, and I am watching the clock for you guys because I always know what time it is, and we're getting close to the end, so I'm going to just say pretend, okay? Pretend. And so I am going to write the word, no, I'm going to type the word pretend, because you wouldn't even be able to read it if I wrote it. Okay, so here we go here. Pretend we did the confidence interval and got, okay, and now you'll see what I was writing. So pretend we did the confidence interval, and I would really do this, except we don't have time to do it now because I'd have to go back to Excel and we'd have to do all that calculation and stuff. But pretend that we did the confidence interval, and we got this as the confidence interval, and now I'm going to use my chalk again. But we got this, that the confidence interval, and remember, these are numbers on the real number line. Okay, and so what we're going to do is suppose, and p hat's going to be smack dab in the middle of this, so suppose I get 0.34, and that means that, by the way, I could have asked you what the other end is, because it's always going to be the margin of error. So it's 5, and so this is between, so we did the confidence interval based on that sample, and we get a confidence interval. And again, I'm just making this up. We really didn't do the calculation, but pretend we did. On the test, I might ask you to do this. But we got 0.34 and we got 0.44 as the endpoints. Okay. Monica just said, okay, I'm going to fix it. Hold on. I'm going to say pretend. I love pretend. Okay, and so pretend that p hat was 0.39, and Monica said she did a recalculation, it really was something else, but pretend it was 0.39. Okay, so that means, pretend it was 0.39 is the p hat, and then we did the confidence interval drill, and we get this 0.34, and we got 0.44. Okay, I want everybody to think, what do we do? Do we reject the null hypothesis, or do we fail to reject the null hypothesis? And I want you to have some skin in the game. By the way, you really are going to have some skin in the game whenever we go to do the high stakes assessment. But right now, it's just for fun. But I am asking you to figure out what it is, and I'm going to type what the answer is here. Okay, and so it is that we, and you will see what it is in a minute because I'm going to type it and reveal it. And the answer is you fail to reject. Because you see, is 0.37 in that pretend interval? And the answer is yes. So you fail to reject. Now suppose that had been different and 0.37 wasn't in it, then you would reject H0, and that says that the evidence supports the alternative hypothesis. Okay, so that's good. And to tell you the truth, I think I talked about this all I plan to. Next period, we will, talk about, the final. We'll practice a little bit of a dry run for the final protocols. And I expect we'll start talking about physics the next term. And I don't mean the next term, I mean the next time this class meets. And the midterm is going to be on the 18th. And some of you might want to be going to Linda's GSG or coming to my office hours or going to see Cher Martin or something like that. Time is precious. Each day must count. Do the math. It'll make you strong. Good night, everybody. Be safe.
Wait, Professor, can I ask you a question?
Looks like he left already.
That's okay. That's okay. It was just about the midterm, but they're talking about it next week. Okay.
Bye, guys.
Bye.
Bye.
Bye.